Hi, everyone. Thank you all for joining. I'm Itay. I'm a software architect in Wix. And I'm going to share with you the story of how we built this library called Repluggable. And I'm going to start by giving a little bit of context. In the last 5 or 6 years at Wix, I've had the pleasure of working on various generations of website builders. And take my word for it, website builders are complex applications. And not only they're complex application, the complexity grows with time. The more we need more features, we need more product. And as the time progresses, complexity grows, and this application become hard to manage. And each time we encountered the same issues with scaling the application and add more features, with growing complexity and how to manage this, which led us to writing the Repluggable library. So what we're going to talk about today. First of all, I'm going to explain what led us to writing this library and what were the issues and the challenges. Then I'm going to explain how the concept of Repluggable works and how we built Repluggable. The next thing is I'm going to explain about the entities in Repluggable and how stuff inside Repluggable connects. This is going to be a confusing part of the presentation. You're welcome to write your questions, and I will answer them in the end. After this, we'll see a demo that will hopefully turns all your question marks into exclamation marks. Then I'm going to tell you about some other features in Repluggable, and then I'll answer your questions. So without further ado, let's start. Let's begin with introducing the problem. So the modern, naive project structure is usually a dependency tree. We have various modules that depend on other modules in order to function correctly. And in this paradigm, modules really know a lot about other modules and depend on them specifically to function correctly. And if we'll zoom in and take one of the module, and let's say we want to maybe reuse it in another project. Maybe we want to deploy it in a different CI pipeline. We want to build it differently. We want to replace it. We have huge pain points there because everything gets messed up and we get spaghetti code and something like the earphone code left in your pocket. So if we'll try to list the bullets of the issue. The tree structure make it hard to reuse modules in other projects. It make it hard to take parts and replace them with other parts. It make it hard to comprehend and refactor because the concerns of modules leak into one another, and you have to understand the entire ecosystem in order to replace and relocate things. And it's really hard to extend, and we'll elaborate about this one shortly. It's really hard to migrate between projects because modules are aware of their environment. They are not agnostic. They rely on specific other parts in order to function correctly. And the build and the CI and the deployment is really inflexible because it's really tied to the project structure. So what we wanted to introduce is an entirely different paradigm. We say we don't want the dependency. The dependencies makes it hard for us. So we don't want dependency. We start with an empty application that has no content, no features inside, and then modules connect in parallel to each other, orthogonally, without being aware of each other, with a strict boundary between what module knows about the world, and they have equal weights. And then you can assemble pretty much any application you want with a sum of feature you put in the empty application. And this gives us a lot of order and structure to the project. So instead of this tree intertwined structure, every model is aware of the application, we get this modular structure where modules don't know anything about other modules and only know the host, the empty application, and they only communicate with it. So how do you make it work? Because dumping all the dependencies is pretty arbitrary statement because we need dependencies in the real world. So let's dive a bit deeper. Let's take an example of part of an application. And here we have two modules. One module is a toolbar of an application. And then we have another module that handles, that creates a button for saving your work. In order to integrate the save button into the toolbar, the most naive, straightforward approach would be to import the save button in the toolbar, and when rendering the toolbar, you want to render the save button inside. And the big issue with this is that for each feature that we want to add, for each new button, we're going to have to implement the new button or new feature, and then we're going to have to go back to the toolbar and add another import and add another rendering part to the toolbar in order to render what we imported. And now, to make things even more complicated, let's say we have another implementation of a toolbar. Maybe it's on a different project that want to use the same save button. Maybe it's a different variation of the toolbar. In any case, when we want to add a new feature and have it in all the toolbars, we have to go ahead and implement the button, and then go to each one of the toolbar, import it, and then again go to the rendering part and add the import. So it becomes pretty frustrating, right? So what we wanted to do is to reverse the arrows. To instead of getting more dependencies, we want to have more injections. So we don't want toolbar to be aware of the existence of save button. So instead of what we have before, where toolbar knows save, toolbars leave an empty placeholder in order for whatever is going to come, whatever features that is going to be extended, to be injected into the toolbar. And it's the responsibility of the save button to say, I want to exist inside the toolbar and inject itself into the toolbar. And that's true for any other feature that wants to be inside the toolbar. It's going to have to inject itself into the toolbar. So in order to achieve that, we need toolbar to expose some sort of an interface, or a way to communicate in order to inject content into this toolbar. And save will have to take this interface and contribute its own content into the toolbar. So in this way, toolbar is not aware of the content, and it's the responsibility of the save or any other feature to inject itself into the toolbar. So if we work on the, if we look at it in the entire ecosystem, the host, which is the empty application, its main responsibility is to be the registry for the implementation of interfaces. And what do I mean by that? When toolbar introduces itself into the host, it exports an interface to the world and register in the host its implementation of toolbar. Then when save comes, it's not aware of the toolbar itself, it's just aware of the existence of an interface of toolbar. And this is the only thing it knows about the world. It knows the interface of toolbar and that there's a host. And then it approaches the host and say, I want the implementation of a toolbar interface. Give me the implementation and I will contribute my own content. And in this way, we can replace the toolbar and give a different implementation for the same interface. And the code for save does not have to change and it doesn't have to be aware who implements stopbar and in what way. So in this way, we generate basically a contract, and the contract becomes the most important thing in the application because it defines the integration points between the modules. So in order to introduce this contract, when we create a module, we create an interface and the key. And the key is going to represent the interface in the world. Then we create an implementation for this interface that is going to be registered. And when we export them separately. So when we define the dependency, quote unquote dependency, it's not a real dependency, we define that we depend on the key because we don't want to depend on a specific implementation. We just say that we want a specific contract to be fulfilled. So we essentially create an agnostic system where modules are not aware of each other, and instead they only rely on specific contracts to be fulfilled. And when these specific contracts are fulfilled, they are ready to execute their own logic without being aware who accepts the content they contribute. So if we compare what we had before to what we have now, before we had modules that are hard to reuse in other projects, and now we get modules that are completely agnostic of their surrounding. They just need specific contract to be fulfilled. So before we had some modules that are hard to replace. Now modules don't care who implements the contracts they need. They just you just eject the previous implementation and inject a new implementation. It becomes really easy to comprehend and refactor because everything is well scoped and the contracts are really clear. The integration points are really clear. It becomes really easy to extend because all the extension becomes from the outside of the module. And it's really easy to migrate modules between projects. It's literally as easy as cut and paste them in a different project. And the operation, the deployment become really agnostic to what modules we have because it's completely agnostic. It becomes completely agnostic, and you create whatever deploy cycle you want. And also the build become completely free. You can build part of the application in one way and another part of the application in a different way. You simply don't care when you create the project. We also get better design because things are better scoped. You can't let concerns leak from the outside because the boundaries are really clear. And also, as experience showed with our developers, we get really superb velocity for adding new features. So this was the concept. And now I'm going to introduce the entities inside Repluggable, which is going to get a bit confusing, but hopefully in the demo, you'll see how everything connects. So we'll start with APIs. And APIs are practically the bare bone of how modules communicate between each other. APIs define the contract of how modules, what module can rely on from the outside world, and how they provide their own services and how they communicate with the world. So basically an API, when we define an API, we define a key. A key is simply an object that have a suitable interface. And the key will represent this interface in the world. This key will be public for everyone to use. And then we're going to have implementation for a specific module for this interface, which is going to be exported separately and contributed into the host. And this is private implementation of a specific module. Another part in Repluggable is extension slot. And extension slots let us, is a service that we get from Repluggable in order to build the modular features. It gives you the tools in order to accept contribution from other modules, from other parts of the application, and add them into your module. And it will handle this contributed module for you. So essentially, it's an empty box that you can put whatever you want inside. It can be components, it could be functions, it could be objects, anything. So if we look at the top bar, when the top bar wants to create a contribution mechanism, it will create a slot that Repluggable provides for it. And we create an API that when it gets contribution, it will put it in its own slot. So when save initializes, it creates its component and approaches top bar API and contribute its contents, and top bar will in turn put the component in its own slot. The other parts we have in Repluggable are entry points and shells. Entry points is the way we package the content and contribute it into the system. An entry point is essentially a way to take module content and add it to the app. So if we examine the interface of an entry point, in an entry point we can define a get dependency API, which contract we need to be fulfilled in order for our own module to be able to run. Then we can declare our own API, which contracts we are going to provide to the application so others can rely on our service. Then we have attach and extend in order to add our content to the system. We receive a shell from the host. We'll see in a minute what this means. Then we have an ability to clean side effect if for some reason the model is ejected in runtime. And we have a unique name and the layer, which we'll dive deeper into in the end. So entry points or modules can be attached or detached at any given point in runtime. And they guarantee for us that every contract we need from the application is going to be fulfilled. If for some reason one of the modules we depend on is being ejected, we are going to be ejected as well and going back to the pending list. And for each and one of these entry points, we provide a terminal, sort of a scoped communication, which we call a shell. A shell is the scoped communication terminal for the entry point in order to contribute its content. So, for example, if we request from the application give us a store, it will give us a store that is scoped for our own module. So if we examine the interface of the shell, we can request an API. We can request a specific some implementation of a contract that we depend on. We can request a part of a Redux store. We can declare an extension slot that we saw before, in which we will be able to contribute content to and add our own stuff into. And we have contribute API, which let us the opportunity to implement some sort of interface for others to be able to use. So they will be able to call get API and get our implementation. And it have the name that's compatible to the entry point and more stuff we won't talk about at this time. So in order to summarize the entry points and shell, each time we want to add content into the system, we give the host the entry point. The host will create a shell for it and provide to the entry point in order to take its content and add it into the application. So if we examine what we looked at before, the contribution mechanism, instead of the save talking directly to API, we know this doesn't happen. Save is not aware of the specific implementation of Tobar. Instead, we have this hub, the host, the empty application. And when we want to register the implementation of Tobar, we are going to create an entry point in order to package the module. And we're going to take this API we implemented in the Tobar module, and we're going to contribute this API into the host. And when Save wants to use this API, it will request it with get API. And when we call get API, we'll get the implementation that Tobar created for us, and then Save will be able to contribute its component into the host, which Tobar will in turn put in its own slot. So to summarize, we in this way we take modules and we layer them on top of each other in order to create an application. So when we start with Repluggable, we start with empty slots. We have a slot for UI, for store, and for API. And when we introduce a module into the system, it will contribute its API into the slot of the host. It will contribute a Redux store, a reducer, and it will contribute its UI content. And then when we introduce another module, it will communicate with the API of module A, in which way it will be able to add its own content into the component that module A introduced. And when we add module C, it can communicate with the API of B and A in order to contribute its own content. And when, if for example, module B is ejected, since module C depend on it, it will be ejected as well, and it will remain in a pending list. So if module B returns, module C will return as well because it can now function. So before we go into the demo, let's examine how the code of an entry point looks like. So we have a specific name for the entry point. Then we have the opportunity to declare an API. We declare which contracts we are going to contribute to the system. Then we have the opportunity to say which contracts we need from the system. In this case, this entry points is going to contribute the implementation for my API and wait for the implementation of other API to be registered in order to be executed. Until the implementation of other API is registered, nothing can in this entry point can run. So it remains in the pending list until someone registers other API. Then we have the attach phase when we get the shell, the scope communication from the system. And from the shell, we can use contribute API in order to contribute an implementation for my API, in order to fulfill this contract for other modules to be able to use. And then we have the extend phase, where we have the, here we can use the contracts we requested in get dependency API. We can create our own content and call functions on the other API. And another cool thing is that since get API is a generic function and all the keys represent typed interface, we get auto-completion because the generic function extracts the interface from this key. Right, so let's go to the demo and see how everything connects. So here we have a Wix product called Editor X, which is built on top of Repluggable. And every single part of this application is a Repluggable module. And I'm going to start by extracting some sort of APIs and variables from the debugging utilities. The first thing I'm going to do is to look at this part of UI. And I happen to know that this is called breakpoints bar. And now I'm going to eject this part of the system on runtime. I'm going to call remove shell and I'm going to remove this entry point. So when I execute this, this part of UI is going to disappear because I took part of the application and simply ejected it. The next thing I'm going to do is I'm going to define a new API key. It's going to be called Color API. Next, I'm going to introduce a new module to the system. It's going to be called Color, and it's going to declare that it's going to fulfill the interface. It's going to contribute the implementation for Color API. And in attach is going to call contribute API and say, whoever is going to request Color API, this is the implementation I want it to have. So the Color API interface contract is going to provide get color, which is going to return the color black. Next, we're going to add an entry point that is called shape. So what's shape going to do? Shape is going to depend on a contract from the system called Color API we just contributed, and another API that I extracted from the debugging utility. It's called a Workspace API. We're going to get a log when it's going to be attached to the host. And when all of this, when it knows all the contracts are fulfilled, it's going to request the implementation of Workspace API. And it's going to call a function called contribute floating component, and it's going to contribute the component to the Workspace API. So this is simply a div that is fixed position. It's going to, in order to style it, it's going to request the implementation of Color API. It's going to request whoever implemented color. I want the function get color in order to set the background for this component. And we're also going to get a log if, in some case, it's going to be detached from the system. So I'm going to add this, and I'm going to get a square, a black square. So now what I'm going to do is I'm going to remove the entry point color. And as you recall, the entry point color contributed the Color API. So what's going to happen is that shape is not going to be able to execute because it needs Color API in order to execute. So when I'm going to call color, it's going to be detached, and the square is going to disappear. So the next thing I'm going to do is to add the new entry point, which now we don't have a Color API because we detached the shell that contributes a Color API. So we're going to contribute a different implementation for the same API. And instead of getting given an implementation that's going to give the color black, we're going to give blue. So when we execute this, shape that was pending is automatically re-injected into the system, and it's going to get the new implementation we registered. So basically, it gets whatever interface is injected for Color API, and it doesn't care who implements the Color API. It's going to get the color from this specific implementation. So in this way, I can add more and more modules into the system. Here, for example, I'm going to add a new module to the system that's going to depend on another API I took from the debugging tools. And it's going to contribute a new component into the system that's going to appear here. So in this way, we create more and more modules that extends and contribute content into other parts of the application. So that's it for the demo. And before we go into the questions, other stuff that we have in Repluggable, we have a feature called layering. Now, since modules are really unaware of each other, and every API can use another API, we can easily get into circular dependencies. So what we did in order to tackle that is we sort of categorized modules and give them specific layers according to the hierarchy we desire in the application. For example, we can have a layer for UI, business logic, and data layer, and every API will be able to use only its APIs of its own layer or below. So this way, for example, we must separate, for example, when we contribute save logic and when we contribute save UI, so we'll be able to share the business logic with other packages. So another thing, other things we have in Repluggable, since we control the hub, we can wrap a lot of APIs and interfaces, and we can inject monitoring and logging utils and BI logging into the system directly without parts of the application being aware of it. Also, since we control the flow of when parts of the application are introduced, we can load modules whenever we want. We can load them lazily. We can load them conditionally. We can load them in whichever way we see. And we can introduce a lot of performance, memorization, and caching mechanisms out of the box, and a lot of other cool features. So you're probably going to ask yourself, this is awesome. Can we use this in our own application? And my answer is a resounding yes. You can use it in your own application. We recommend using it. We use it, and we're happy to use it. It's open source, so feel free to use it. And thank you. That's it from for this presentation.